then I should be able to get sodium chloride. Okay, sodium chloride. So, and also just in the naming, we have to be very careful. So you always start with a metal, which is sodium, and then you also start with you end with a non-metal, which is chlorine. Okay. So now, moving out now, we can now see. Okay. So this sodium, whenever you're doing a chemical, reaction, so we always use this number. Okay. So this number 11 is a number that you're going to use in order to determine how many of the valences, okay, how many valences will take part in the chemical reaction. So this 11, you start now configuring it, okay. There's what we call electronic configuration. So when you start configuring 11, you say 2, 8, 1. Okay. Meaning that this one, the 2 there, you add it with the 8 there, and then also you add the 1 there. You should be able to get back to 11. Okay. So meaning you have 11 equals to 2 plus 8 plus 8 plus 1, then this gives you 11. 11 equals to 11. So when you add all this together, it should be able to give you 11 electrons. Okay, those 11 electrons. So we are just more like dividing them. Okay, we are just dividing them so that we know which one of those will take part or in the chemical reaction. Okay. Again, we are moving on to that. Okay. So now, when we talk about these numbers, 8, 1. Okay. All these are what we now call. We call all these numbers electrons. Okay. So these are electrons. So the first electrons is that 2, and then followed by 8, followed by 1, which can also be presented by saying you have something like in terms of shells. Okay, in terms of shells. Okay. So what you do is that this is the first inner circle, is the first shell. So you put only the 2 electrons. Okay, so you put 2. And then the second one is 8. Okay, the second one is 8. So you put 80 electrons. You put 80 electrons. Oh, 6. And then in the last shell, the third one, okay, the third one has got 1 electron. So you just put it anywhere, okay, anywhere. Okay, so, and then at the middle there, you can just say you have sodium. Okay, so now what I want you to understand is that when you look at these electrons in the outermost shell, okay, So this one, okay, this one on the third shell, which is just one, okay. So this is an electron that will take part in a chemical reaction. So this is what will take part in a chemical reaction. So one electron So this one electron is the one that will take part in the chemical reaction. So coming back, you go to the chlorine also. You go to the chlorine. So when you look at the chlorine, okay, so the chlorine has got 17 down. When you check that out on the periodic table, so you have to configure this 17 so that you can know how many pieces of electrons makes up the 17 as a whole. Okay, as a whole, and then you can figure out now how many of the atoms, how many of the electrons will participate in a chemical reaction. So with chlorine, we've got 17, so it's that 2, 8, 8, and then we have 7, okay. So what is happening is that in the first one, it is always 2, okay. In the second one, it is always 8, and then in the third one, it is always what to add up to what we have as a total, okay. So therefore, now for chlorine, it is an exception, okay. The last number there, okay, is what now takes part in the chemical reaction. But if this last number is 5 and above, okay. So if the last number is 5 and above, then you have to say 8 minus that last number, which is 7. And then this gives us 1. Okay. That gives us 1. So meaning that chlorine has 1 valence. So chlorine has got 1 valence, okay. That's what you need to understand, okay. So now finally we're going to say now sodium plus the chlorine equals to sodium chloride, okay, equals to sodium chloride. Now you see that when you looked at okay, so when you looked at sodium had 1, and then also chlorine had 1. So this is going to be sodium chloride, okay. Hello? Okay. So what is going to participate in a chemical reaction is that this one right here, okay. Let's see. So this one is going to be exchanged, come to chlorine, and then this one shall be also exchanged, come to sodium. So they are going to swap the valences. Those one will exchange. Okay. So now what will happen is that we are going to have sodium 1, chlorine 1. Now, since these are numbers that have swapped or exchanged, these ones, since it is a 1, okay, so there is no need for you to show those ones, okay. So I'll show you where you can now see the other ones, okay. Like if those numbers were not like the 1, apart from the 1, like 2 and above, you have to just show them, okay. So this is going to be just like okay. So this is just going to be like that. And for us, we understand that how do we balance this one? Since there is just 1 sodium there, and then also 1 chlorine, there should also just be 1 sodium and 1 chlorine atom. Okay. Now let us look at the other one. Example 2. So example 2, where you have hydrogen. So hydrogen plus oxygen, then you are going to have H2O. Going to have H2O. Okay. So now when you look at hydrogen, it has 2, and then also hydrogen on the right side, it is 2. So the number of atoms in terms of hydrogen is that hydrogen we have got 2, and then also there is a hydrogen 2. Okay, so hydrogen is already balanced. Okay, and then now let's move on to oxygen. So oxygen, there is 2. So oxygen has got 2 on the left part, this part. Okay. So this is the 2. Now on the right part, the O there, just the O. Okay, it is just 1. So this one will be oxygen on the right. This is just 1. So 1. Now this becomes very difficult because you can see that so where do we tackle now? Since oxygen is 2, oxygen is 2 on the left, and then on the right, oxygen is just 1. So oxygen on the left and then oxygen on the right, they are in the different ratios. So they kind of mismatch. So we have to balance up by only going to this lower number. Okay, so by only going to this lower number. Okay, this lower number. So what you do is you put now you put now hydrogen plus O2 so we are going to put the 2